students, welcome to mathgotserved.com. In this clip, we're going to be taking a look at how to express multiple logs, either sums or differences, as a single log, and how to simplify the resulting expression using the properties of logarithms. To get us started, let's do a real quick review on the properties of logarithms. We're going to be taking a look at 4 properties. The first one is the product property of logarithms. Okay, so if you have the logarithm of the product of two numbers, that's the same thing as the logarithm of the sum of the factors log base b of x plus log base b of y. This basically highlights one of the main uses of logarithms. It helps you to convert the product of two numbers into logarithms, where you can just find the sum of the logs and use the inverse log to generate the product. All right. And then we also have the quotient property of logarithms. So if you have the quotient of two numbers, x over y, it can be written as the log base b of x minus log base b of y. So these two properties basically helps us to see how log converts multiplication into an easy operation of addition and division into an easy operation of subtraction. Okay, we also have the power property of logarithms. So basically converts exponentiation into multiplication. So if you have log base b of a to the x, that's the same thing as x, you power down the exponent, log base b of a. And then the last one helps you with simplification, which is the inverse property. So if you have log base b of b to the x, if the base of your log is equal to the base of your exponents, those two cancel out and you're just left with the value of the exponent. All right, so the instructions for the examples that we're working on are for us to express as a single log and simplify if possible. All right, for question number 1, let's say we have log base 3 of 81 plus log base 3 of 3. So the first thing we're going to do is try to attempt to condense these two logarithms using the product or quotient property of logarithms. So here we have the sum of two logs. Remember that the sum of logs is the product of the logarithmic arguments. Okay, so in this particular situation, log base b of 81 plus log base b of 3 is log base 3. We're going to find the product of these two arguments, 81 and 3, because we know that when you multiply in the log world is equivalent to, now when you add in the log world is equivalent to multiplication in the regular world. All right, and then when you subtract in the log world is the same thing as, is equivalent to division in the regular world. Okay, so here we have a summation, so that's equivalent to multiplication. So we're going to multiply the two logarithmic arguments, 81 times 3. When we multiply that, we get log base 3 of 243. Now, is this reducible? If we can express the logarithmic argument 243 as a power of 3, then we can use the inverse property to simplify that. Okay, so let's exhaust the powers of 3 up to beyond 243 to see if we can hit this target. So 3 to the 0th power is 1. 3 to the first power is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth power is 81. 3 to the fifth power is 243. Jackpot. This is the exponential equation that we're going to be using to make the substitution. Okay, so we're going to replace 243 with 3 to the fifth. So we're going to have log base 3 of 3 to the fifth power. Now, since the base of the log and the exponents match, we can have a cancellation action happening right here. So these two cancel out and you're just left with the exponent. And your final answer is going to be 5. All right, let's take a look at question number 2. So for question 2, what if we have log base 2 of 64 minus log base 2 of 2? All right, so in this particular case, we're looking at the difference of logarithms. All right, so when you have the difference of logarithms, what is it in the regular world? The subtraction of logarithms is equivalent to division of the logarithmic arguments in the regular world. So these two arguments that we have, 64 and 2, we're going to be finding the quotient of them using the quotient property. Okay, so this becomes log base 2 of 64. The one that comes first is the numerator, divided by the one that comes second is the denominator. 64 over 2. Okay? If we simplify that, we have log base 2 of 32. Now, can we express 2 as a 32 as a power of 2? Well, let's see. So we can reduce it. So 2 to the 0th power is 1. 2 to the 1 is 2. 2 to the second power is 4. 2 to the third times that by 2 is 8. 2 to the fourth is 16. 2 to the fifth is 32. Oh, there you have it. Excellent. So this is the one that equation we're going to use for our substitution, okay? So we're going to replace 32 with a power of 2, namely 2 to the fifth power. So take away 32 and replace with 2 to the fifth. Now log base 2, the base of the log and the base of the exponents are the same, so they cancel each other out. And then that exponential term is going to be your final answer. And the answer here is also 5. Okay, let's box that. All right, for question number 3, let's say we have log base 3 of 2 plus log base 3 of 5. All right, so let's express this as a single logarithm first. So in this particular case, we are looking at the sum of two logs. So sum of logs in the real world is a product. So we're going to be multiplying the logarithmic arguments 2 and 5 since we have a sum. So we're going to have log base 3 of 2 times 5. When you multiply that, you have log base 3 of 10. So can you write 3 as a power of 10 so we can reduce it? Let's see. So 3 to the 0th power is 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. So 10 is somewhere here. Okay? 3 to the second is 9, 3 to the third is 27, so it's impossible to write 10 as a power of 3 because it doesn't show up in the powers of 3's chart. So what does that mean? That means that this is our final answer. Okay, let's move on to the next one, question number 4. What if we wanted to find log base 10 of 250 plus log base 10 of 400. All right, so we're going to express it as a single log first and then simplify if we can. Okay, log base 10 of 250 plus log base 10 of 400. When you add in logs, is equivalent to finding the product of the log arguments in the regular world. So it's log base 10 of 250 multiplied by 400. All right, when you multiply those numbers, you have log base 10 of 100,000. So can you write 100,000 as a power of 10? Absolutely. You just look at the number of zeros. You have 5 zeros. So 100,000 is 10 to the 5th power. And then using the inverse property of log, since the base of the log and the exponents match, we can just cancel that out. And we'll have our final answer of 5. All right? So there goes the answer to question number 4. All right, let's take a look at one more example. Question number 5. Let's say we wanted to find log base 5 of 1/2 minus log base 5 of 50. Okay. Oh, quick correction here. Second logarithmic argument is actually 1/50. Okay, so let's take a look at this one right here. So in this particular problem, we have the difference of two logs. Log base 5 of 1/2 minus log base 5 of 1/50. So when you're looking at the difference between log is equivalent to the quotient of the logarithmic arguments. All right, so it's going to be 1/2 divided by 1/50. Okay, because we have a difference here. All right, so how do we simplify the quotient of two fractions? We can drop, change, flip, right? Multiply the first fraction by the reciprocal of the second. So this becomes log base 5 of 1/2. So drop, change it to a times, and flip the other one, times 50/1. And then when you simplify that, you have log base 5 of 2 goes here 1, 2 goes here 25 times of 25. Can you write 5 as a power of 2? I'm sorry, can you write 25 as a power of 5? Absolutely. 25 is 5 to the second power. Okay, now we can use the inverse property of logs to simplify, cancel these two out, and your final answer is going to be 2. All right, so that's basically how you use the properties of log to express multiple logs as a single log and simplify the resulting expression. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel with your likes, subscriptions, and comments. We'll see you in the next video. Goodbye.